Welcome everyone, and thank you for joining me for Handle Security DNS Protection dedicated session. My name is Alina Marie, Webinar Program Manager at Handle Security, and I will be your host for this event. Some of you might already be familiar with me from our previous sessions, but for those of you who are attending our webinars for the first time, please allow me to quickly share a few things about myself. Over the past 15 years, I worked for companies such as HP, Oracle, and Optimize, where I had different roles in IT security, information technology, and compliance. I have a strong passion for technology, and I always try to stay in touch with the latest and greatest. And among other things, I'm also passionate about traveling, cars, and photography. It's a real pleasure to have you all here today for this session. And I would also like to introduce my guest speaker for today, Valentin Russo. So, Valentin, welcome, and please share a few things about yourself.
Hello everyone, and thank you for inviting me, Aline. I am Valentin Rus, and I'm a machine learning engineer. I started studying AI during my master's degree in machine learning and robotics from the University of Surrey, and then moved forward towards working in the AI research and development field. And I've been working in this field for a while, and I had the opportunity to work on many projects from many fields like health and safety, academic research, smart cities, innovation labs, and lately in cybersecurity. In my current role, I lead the machine learning engineer and research engineering team. And today I would like to talk about how AI can be used for threat hunting and prevention in cybersecurity.
Thanks a lot, Valentin, and once again, welcome. All right, so here's the agenda for today. First, we're going to talk about who we are as a company, what's our mission, goal, and purpose. And then we'll focus on DNS security. We'll explain what is DNS, how does it work, what attack vectors can be used against your organization through DNS, best practices around better protecting your DNS communication, and how AI and machine learning can be used for threat hunting and prevention in cybersecurity. And of course, we'll also talk about how we can help you obtain rock-solid DNS security as well. Also, towards the end of the webinar, we're going to have our Q&A session. Please type in any questions you may have in your question box. And at the very end of the webinar, we'll also have our giveaway. So bear with us until the end to find out what's that all about. All right, so for those of you who haven't heard about us, Handle Security is a leading European provider of cloud-based cybersecurity. The Handle name originates from the Northern mythology, where Handle is the guardian of the Bifrost, and the Bifrost is the only way in and out of Asgard, which is the realm of the Norse gods. And if you're familiar with the Thor movies by Marvel, Handle was the ultimate guardian, basically the superhero that was wearing the gold-plated armor, played by the actor Idris Elba, if you remember. And our story as a company started back in 2011 at the DEFCON Capture the Flag Challenge. And for those of you that are unfamiliar with the event, DEFCON Capture the Flag is a competition that gathers teams from all over the world. And that includes teams from the likes of the FBI, the NSA, and many other security agencies and services. It's a very pro competition. And there we had our own team that very early in the competition understood that instead of focusing on live interactions with the enemy team, they could instead successfully defend their machine by blocking every single entry point into the server through automatically patching any vulnerable third-party applications and by monitoring all the DNS traffic that was used by the enemy team that was trying to gain access into their server. And of course, our team won. It was actually for the first time in the competition when a non-US team has won it. And we managed to do that for 2 years in a row. And the intelligence we gathered back then in 2011 and 2012 was merged into the Hadna core product that later on became Thor Foresight. And in 2014, when we took the product to market, we were actually able to completely map out the malicious infrastructure that was used to deliver the original CryptoLocker ransomware. And we handed over that intelligence to the FBI, intelligence that proved crucial for the success of the operation, as the FBI managed to locate the malicious servers and, of course, take the entire cybercriminal organization into custody. And even today, we're working alongside Europol, the US Department of Justice, and the NC3, which is the Danish Police Cybercrime Unit, in a safer digital world for both consumers and for businesses. And on a different note, we are honored to have been chosen by the Royal Bank of Scotland as their recommended cybersecurity solution for all their business customers. So now that we got acquainted, let's talk about DNS. In order to know how to better protect it, we must first understand what is DNS. So the definition is right here on the screen. DNS is short for Domain Name System, which is a hierarchical and decentralized naming system for computer services and other resources connected to the internet or a private network. And the DNS was built in the early 80s with the purpose to solve issues that were posed by the very early internet, which is called the ARPANET. And that used to hold names to IP address translations in a single table on a single host. And in 1983, Paul Macapéris proposed a new framework that involved a dynamic distributed system, the DNS. And in 1986, the DNS became one of the first internet standards. So instead of looking up host names, it provided readily recognizable IP address names, enabling more convenience for regular usage. And you should think about DNS like a phone book. So whenever you want to call your family or your friends, you don't have to necessarily remember their phone numbers. You just go into your address book and you type on their name, or you put their names in your phone book, and then you can dial. And it works the same way for the DNS. Instead of remembering and inputting IP addresses for the servers that you're trying to access into the web browser, you would instead put in the name of the website. So for handle security, for Google, for LinkedIn, Twitter, or of course many others, and you just hit go, and then you'll be able to access that server. But in order to get a little bit more details about how DNS work and get a little bit more technical about it, I'll let Valentin kind of give us more details around that.
Okay, well, when you write in our browser a DNS request like google.com, the network will go through a determined pipeline to find the associated IP address. So first of all, the computer will search into the browser cache memory to see if the IP address for google.com is there. Now, if the IP address is in the cache memory, the user can go straight to the website. Otherwise, the computer will send a request to its configured DNS server, and every operating system has a configured recursive name server that it's usually the internet service provider or Google 888 server or the security product. After that, the DNS server will ask the root server where it can find the IP address for google.com, and there are 13 root servers placed strategically around the world. And the main idea is that a root server doesn't know the IP address of a domain, but it knows where is the top-level domain server for each DNS. For example, google.com has the .com top-level domain, and the root server will redirect the DNS server to the .com top-level domain server. And after that, the DNS server can ask the name server who manages the domain about its IP address and will receive it. Well, when the DNS server receives the IP address, it saves it in its cache memory and sends it back to the user. And finally, the user accesses the actual website server.
Thanks a lot, Valentin. So why is DNS attractive to hackers, to malicious actors?
Well, Aline, DNS is a vital digital structure and one of the Internet's foundations that integrates everything related to the IT infrastructure. So basically, through DNS travels all the information that circulates between servers and users. So it's no wonder that it has turned into a very attractive target because it allows the attackers to replicate and scale their operations.
All right, and that's exactly what we've seen in the IDC 2020 Global DNS Threat Report that says 79% of organizations were victim of DNS-based attacks. 75% of attacks were not mitigated automatically, and DNS attacks determined application downtime for 82% of the organizations. And on average, each organization was affected by 9.5 DNS attacks, and the average cost per attack was around $924,000 US. So, Valentin, we see the attractiveness of DNS for the hackers, but can you tell us how the DNS can be compromised?
Well, there are multiple ways in which a DNS can be compromised, like DNS rebinding or spoofing or hijacking, but I believe that you can split those into categories. First of all, the DNS server can be hacked by compromising the way in which the DNS actually works, or by exploiting some vulnerabilities from the servers that run the DNS services.
And what type of malware are mostly delivered through DNS, Valentin?
Well, there are many attacks that run through DNS requests like CNC or phishing or typo squatting or even classical malware. But I believe that the two most common are CNC and phishing by far.
All right, so thanks, Valentin. Let's talk a little bit about this type of DNS abuses then. So the first one is typo squatting. That's also called URL hijacking or sting site or a fake URL. And it's a form of cyber squatting and possibly brand jacking that relies on mistakes such as typos that internet users make when putting in a website address into a web browser. And should that user accidentally enter an incorrect address, they may be led to an alternative URL that's owned by a cyber squatter. And can you tell us, Valentin, some of the most common type of squatting abuses?
Well, Aline, there are multiple types of typo squatting attacks, and the main idea behind this type of malware is to try to replicate the DNS server and the actual legitimate website. I believe that it will be easier to understand to an actual example. So starting from the domain example.com, we can have the following variations. The first one, example.com with E instead of A. It's a very common misspelling error since there are foreign languages in which example is written with E instead of A. Or we can have an attack based on a typo, an actual error in writing example with characters L and P in a changed order. There are many variations like top-level domain change, and there are 1,500 possible top-level domains. So for example.com, we can have another 1,500 possible variations like .org, .co, .uk. Also, if you talk about top-level domain, we can have an abuse here in which from .com, top-level domain, if you leave out a letter, you can register a website using .cm or .om or .co. As I said, there are many variations. Adding an extra word, use the plural of a word, and many other inventive ideas. But the main idea is that the attacker wants to trick the user into thinking that he is in fact on the legit website. And this is the reason why they are using the same logo, the same content, or the same layouts, because they want to make the malicious website to look as authentic as possible.
Thanks, Valentin. Now let's look at the next attack vector, which is the command and control. So for command and control, we also have the definition on the screen. So a command and control server is a computer controlled by an attacker or cyber criminal, which is used to send commands to system compromised by malware and receive stolen data from a target network. And CNC servers act as command centers that malware use to store stolen data or download commands from. And establishing CNC communication is a vital step for attackers in order for them to move laterally inside a network. And ESG conducted a research, and they found out that 24% of security professionals working at advanced organizations are not very familiar or not at all familiar with command and control communication techniques. 48% of those working at progressing organizations are not very familiar or not at all familiar with these techniques. And 82% of those working at basic organizations are not very familiar or not at all familiar with the communication techniques. So Valentin, given this statistics, I think it's very important to share a few examples of how CNC can be established.
Well, the first step in every CNC is that the attacker starts by infecting a computer, which may sit behind a firewall. And there are multiple ways in which this can happen. So a computer can be infected with a CNC by accessing a phishing email or through a browser plugin or downloading an infected software or attachment. But the main idea is that once the infected file is inside the computer and the communication is established, the infecting machine sends a signal to the attacker's server looking for his next instruction. And after that, the attacker has full control over that computer. And also, those systems can include more than computers. It also works on smartphones, IoTs, almost everything that can be connected to a network. Now, if the attacker has full control over a computer, he can extract sensitive data like financial documents, he can shut down machines, he can reboot machines, and this will disrupt the normal business operations. They can install keyloggers that tracks everything that was written in a computer. It is a software that was designed for copying passwords. They can also infect other computers inside the network because it's easier once you are inside the network. They can set DDoS attacks, and those attacks send requests to a server and flood it with traffic. For example, if they have 1,000 infected computers, they can send 1,000 requests in the same time. And they can be very creative, and they usually are. They don't lack imagination. And the main idea is that you should know that they have full control over the computer. And usually they don't make big moves in one step in order not to be traced by the antivirus or other defensive systems. And what is also important to remember is that CNC works through HTTP requests, so it's a malware that works purely on DNS. Now, the purpose of a CNC is to stay with the host as long as possible, and usually an infected domain can last for up to 7 days after it was created, because after this period, almost all the big companies will have it on its blocked blacklist. And that leads to the question, how can they stay longer for a more extended periods? And the answer for that is domain generation's algorithm.
Can you give us more details about the domain generation algorithms?
Well, I said before that CNC worked through HTTP requests, so they need to send requests to a domain. And if the domain was blocked, how do they know where to send requests? Because as we've seen in the last slide, an infected computer communicates with its bot master using a domain like the ones from the table. What will happen if the domain is blocked? Well, to respond to your question and to solve these blocking problems, they come up with a very innovative idea, and that is that the CNC malware from an infected computer has a function that generates a domain on a determined period. Now, the command server or the bot master tries to register the same domain in the same time, and if it succeeds, it can start again to communicate with its bots. Let's try with an actual example, like the one from the image. The algorithm will choose a random number of alphabetic characters, and after that, will encode the current date that it takes from the infected computer and add it to the sentence. Well, in the end, it will choose a random top-level domain from a predetermined list, and the result will look like the one from the image or the ones from the table. And that being said, the botnet server will generate the domain, let's say suitableloan.cn, and try to register it. Now, on the other hand, the malware from the infected host will generate the same domain and try to send requests to it. And if it succeeds, they can start communicating again. Otherwise, they can try again tomorrow with another domain like specialized every.vn. And also, there are very easy to spot examples like the ones from the left column, but there are also more challenging examples like the one from the second column, depending on the algorithm used in generating those domains. Because in the second table, it's an algorithm that chooses from 2000 English words and combines them in a random order. And you need to know that all of those algorithms are actually arranged in families, and there are many of them. And each DGA family is more creative than the other one. And I believe that the last one that I saw used to send requests to google.com and ask about the conversion rate between dollars and yens. And with the resulting number, we'll encode it and generate a new domain. And this is why we need a very strong DNS protection, because those algorithms generates new domain every day, and the whitelist blacklist approach can't keep up with this number of increased domains. Okay, there is a way to block them. For example, if you have the generation algorithm that uses dates, we know that we can generate domains for 2 years from now, but there are too many DGA families to be able to do that. And even if you blocked the commands today, you will never know if you'll be able to stop the ones from tomorrow. And one thing is for sure, as long as the infected file is still there in the computer, it will always try to connect to its bot master.
Thank you, Valentin. Hopefully, this brings a little bit more clarity on how command and control works. Now, let's move on to the next DNS attack vector, and that's phishing. And of course, phishing is the most common type of social engineering attack, and really refers to the process of gathering a user's confidential details, such as login credentials and credit card numbers. And the attack is usually conducted through what may look like a legitimate website, when in fact it's a fraudulent website. So it basically directs the user to an alternate version of that legitimate website. And once the malicious hacker obtains the target information that they're looking for, they will start using it against them, either against the company or on their against that specific person. And in March 2020, when most countries were on the lockdown that was caused by the COVID-19 pandemic, we've seen a 600% increase in phishing emails. 18% of them were related to COVID-19, and the rise in successful attacks was up 37%. So we expect these numbers to keep on rising, especially in the next couple of months, as lockdowns have returned in some countries or even states. And now with the news of a vaccine, I'm pretty sure that the malicious actors on the hacking scene, let's say, of the world are going to start exploiting this and start using phishing emails around that. So, Valentin, can you get into a little bit more details, maybe some phishing examples?
Well, Aline, as you said before, phishing is the most common cyber attack that we've encountered because it is very widespread since it's very easy to make and it has an incredible success rate that depends purely on people distraction. Because we actually tend to believe easily that a website is legit when we see a very big company logo. And the usual delivering phishing flow is the following. First of all, they will clone the legit website because it's very easy to clone a website web interface as it's public. You just need to right click on the page and inspect or view page source and you'll have all the code there or the front-end code. After that, they just need to change the login page credentials to redirect to their backend applications, and they can upload the phishing kit on their website, on their host, and when everything is set up, they just send phishing emails and wait for victims. And usually, when attackers deliver phishing, they tend to create panic. For example, in their emails, they use phrases like, "Your account has been hacked. Please change the password immediately." Or they use the classical manager impersonate. "We had a security breach. Please log in here and change your password immediately." Or they use the bank scam account. "Your account has been hacked. Please log in here and check the current salt." Because it works purely on human mistake and the attackers have usually very creative ways to create chaos. Also, when the user changes the password, they will get a page like, "Your password has been changed," because the attacker don't want the user to know that they were scammed. It's a very easy trick that works surprisingly well, and I believe that everyone encountered phishing at least once. Some of us might know, some of us might not.
And you're right, Valentin. At some point in our lives, I believe everyone has seen how a phishing website or a phishing email looks like, but hopefully none of us have suffered from that up until now. And we've seen how DNS can be attacked and how it can be leveraged by malicious actors to gain access to the company's assets or personal information. And of course, in addition to other threat preventions and mitigation methods that a company should have in place, such as vulnerability management and email security and business email compromise prevention and privilege access management, and of course, an antivirus, it is also essential to keep DNS security as a fundamental part of the cybersecurity foundation. And next, I'm going to bring up some essential DNS security protection measures that a company can deploy in order to maintain security in DNS. And the first one is the DNSSEC, so the Domain Name System Security Extension. And DNSSEC ensures the security and confidentiality of data, basically serving as a cornerstone for digital trust and preventing DNS threats like cache poisoning. In DNSSEC servers, digitally sign all server answers, and through signature checking, a DNSSEC resolver can verify if the data that came from a valid server is indeed identical to the data on the authoritative server. If that's not the case, the request will be denied. And DNSSEC, it's also able to detect MITM attacks, or man-in-the-middle attacks, thanks to the data origin authentication. However, we must remember that these won't prevent the attack. The next step is monitoring the DNS activity. And of course, by monitoring the DNS activity and logs, a user or an admin can notice suspicious traffic patterns that can, of course, reveal key indicators of compromise. And for example, unforeseen changes in the volume of traffic could suggest malicious DNS activity. And our vector and detection module from our DNS security solution uses machine learning to establish compromise patterns and offers indicators of attacks or indicators of compromise, basically enabling a unique add-on that will enhance the endpoint security. And of course, Valentin and I are going to talk a little bit more about this in a couple of minutes. The next step is protective DNS service. That's for public sector organizations only. So to inhibit the use of DNS for malware delivery, the PDNS was created. This is a free internet accessible DNS service created by the National Cybersecurity Center, and it was implemented by Nominet UK. Protective DNS is a recursive resolver, and what it does, it finds answer to DNS queries. The next one is DNS filtering. That's a great solution to prevent access to malicious domains and web pages. And if you're wondering how DNS filtering works, well, before the DNS resolution is completed, every new request will be checked. And should a web page or domain be known as malicious, then the DNS server will block that request. And of course, the browser will be directed to a web page that states that the website cannot be accessed. And these were a couple of ways DNS can be monitored and better protected. And now we'll move to the next section of the webinar and talk about AI. It's really important for cybersecurity companies to start using AI in their products, because if we, as the defenders, if we don't start doing this, it's going to be bad. The cyber criminals are definitely doing it and will definitely do it in the future. So, Valentin, this is your territory. Please tell us more about AI and how it can be used in cybersecurity.
Well, as you know, AI has a major impact in every field, and in order to cover all the avenues of what artificial intelligence is and how it works, it will definitely require more than the allocated time for today. But I will try to give you a short overview because it will be helpful to understand the basic principles behind our neural networks. So, AI, at its core, it's a branch of computer science that aims to replicate or simulate the human intelligence or the human brain and put it into machines using statistical and mathematical models. And it has multiple subfields like probabilistic graph models, reinforcement learning, natural language processing. But the most common are machine learning, deep learning, and data science. And it will help if you think about a neural network like a black box. You should understand that we feed data, we do some mathematical and statistical calculations in our computer-made brain and expect an output. I'm not going to get into a lot of details about how the learning process works, but it usually requires two phases. First of all, the first phase is the training period, in which the neural network sees a very large volume of data, and after multiple loops of trials and errors and penalties, we can actually measure the error rate and decide if we can end the training cycle. Well, when the training cycle ends, we can enter in the second stage when you use a test data set to measure the accuracy, because usually neural networks learn by heart, and if you only show the network images with dogs with fur, it will not be able to identify dogs without fur. And this is what we call the generalization capability of a network. And usually our day-by-day work is in a loop. We start by doing research on a task. We gather data set, train a network, test it, and depending on the results, we can adjust the network and start again. Well, neural networks need to be fed with a lot of data from all the environments, and they require a lot of computational power. And this is why it's even harder to train neural networks in cybersecurity, because we don't have a lot of data and we can't consume many of the customer resources. Also, detecting a malware is way harder than detecting a dog in an image. Well, because when we measure the neural network accuracy, we want to achieve human expert results, because beating the human level performances has been the goal in academic research and in machine learning all the time. And if you put it in another context, a malware analyst goes through a 6 months preparation program in order to be able to classify files as being infected or not. And this is why the average human accuracy is low, because it's a very challenging task. And now you can imagine how much harder it is for us to train a neural network to do this job, to classify malwares. Well, I will try to present you some of the AI subfields and how they can be used in cybersecurity. So let's start with natural language processing, or NLP. And natural language processing focuses on interpreting, analyzing, and manipulating natural language data using computing tools. So recently, there was a big revolution in NLP that started 3 years ago when Google Brain released a model called Transformer in the paper Attention is All You Need. And it didn't have a lot of popularity back then until last year in February 2019 when OpenAI announced GPT-2, that it's a large-scale neural network that generates realistic text starting from an arbitrary input. And on the right side image, we can see an actual example of how this works. So from the input for today's homework assignment, please describe the reason for the US Civil War. Well, only from this text, the network was able to generate an entire article that I can bet not many people can say that it was generated by a machine and not actually written by a human. Because as you can see, the network adapts to the style of the input since it was written in a very semi-formal and academical style, and it actually presents historical facts. For example, what the second US President Thomas Jefferson said in 1791. Also, the network really did an amazing job in writing about the Civil War, and that is to our next chapter. Is it too dangerous to be released? Well, OpenAI mentioned in their article that indeed the model is too dangerous to be released, and the world is not really prepared for this innovation, and releasing it will not be in the benefit of anyone. They also talked about the implications of fake news and how this model can become dangerous in the wrong hands, and I believe that they really had the point. And that lasted only for 2 months until 2 grad students with an IWS grant reproduced the model exactly and published it on Reddit free for all. And now that everyone had it, OpenAI had no choice and decided to publish the original paper and the original model on their platform. And you can see how it works. Well, on the left corner, we have a text that was generated by me 2 days ago using GPT-2 platform, starting from the idea that Elon Musk released a musical album, and let's see the generated text. While not normally known for his musical talent, Elon Musk is releasing a debut album. Yes, an entire album. The project is titled Musk V, which means it's a collaboration with vlogging icon Shane Dawson. Well, as you can see, the network knows that Shane Dawson is a vlogging icon. It also knows that Elon Musk is the CEO of SpaceX and Tesla, and that he has no musical background. Also, the network associated the music career with Drake and Beyonce, and also knows some of their songs. Let's go now to the right side image. We have a text from the original release that is trying to convince us that recycling is not good for the world. Well, the network used some medical facts, and it says that recycling contributes to obesity and heart disease, that it's very bad for economy, and after explaining how the recycling works, it found some chemicals that proved to be very dangerous for the humanity. Well, the text is so good that it almost convinced me, and now, if it was able to generate such a good text for recycling, can you imagine what fake news articles can it write about religion or vaccine safety or politics? And now maybe you convinced yourself why this technology can be too dangerous. But that's not all, because from there on, it started a real big competition between big tech companies. And starting from the transformer-based model that had 65 million parameters, Google released BERT with 340 million parameters. Facebook released Roberta, that is just a BERT trained with more data and more epochs. And from there on, we changed the league. First of all, NVIDIA Megatron, 8.3 billion parameters. Microsoft Turing NLG, 70 billion parameters. And GPT-3, that was released last summer, 175 billion parameters. And in order to understand what it means, you should understand that it was trained on 10,000 GPUs, and it almost achieved human accuracy in text understanding and generations. It's a very huge model, and training it will cost almost $4.6 million in renting those GPUs. Now, if you compare it with GPT-2 that had 1.5 billion parameters, if that was impressive, imagine a model that is more than 100 times bigger.
And we've been talking about monstrous modules. We've seen, new technologies for which human might or might not be ready. But how can we use these in cybersecurity, Valentin?
Well, NLP can help a lot in the cybersecurity context. And let's talk about our main subject, DNS. Well, usually a domain has a meaning. For example, medium.com or techcrunch.com or facebook.com, PayPal. And a language understanding model can determine the correlation between words. And on the right side image, you can see a representation of word-to-vec embeddings. And as you can see, the network can determine the correlation between words. Let's try with an actual example. King is correlated to man, queen is correlated to woman, all the capitals are correlated to their countries. Paris with France, London with England, Rome with Italy. And now, if a model can understand the correlation between words in a language, why not understanding the correlation between words in an URL? For example, would you please click on a website like the first example in blue?
Oh, I will show you now.
Well, why not?
Because it doesn't look right. I mean, it's just a string of random characters. It doesn't really make sense.
Exactly, because our brain knows that it doesn't have a meaning in any language. And if you can spot them easily, a language model can spot those two with a very high accuracy. What about typosquatting or phishing? Because it is hard to spot them even as humans. Let's try with an example. Facebook with double E and triple O can be very tricky and hard to find it. Also, I believe that not everyone knows that PayPal doesn't have a dash and it has only one L. Well, to respond to that, a language model can easily spot them with a very high accuracy because it already knows the word formation from the training period, and it proves to be an amazing layer of DNS security. Well, and that's not all, because NLP proved to be very helpful in email security too, because nowadays there are a lot of scams that have been conducted through social hacking. And what social hacking means, that using emails, hackers can impersonate CEOs or other employees and use advantage of the people distractions. They can send fake invoices, fake requests, change bank account, change mortgage bank account, change passwords, or many other tricks because they found an unbelievable number of methods for scamming and overpassing the spam filters and the email security systems. And that is because they do a lot of research about the targets and the company. They can find invoice templates, the number of products ordered by a company, the number of employees, their email addresses, their social media accounts, each organization liability. And because of that, it's harder and harder every day to detect those scams because they are very well researched. They can spend years in researching about a company before starting an attack. But with the help of natural language processing networks, we can spot fraud with very high accuracy only by text analyzing, because a neural network can see hundreds of millions of legitimate and scam emails in its training cycle. And that means that a network can achieve security analyst performances and can easily spot those types of attacks. And those networks can understand financial data, personal information requirements, medical and IT terms, and the neurons behind the network will trigger when they find a malicious pattern. And let's look at the statistics. 85% of organizations have suffered from emails attacks already. And this is why I generally hope that nowadays there is no spam filter or email security system implemented without natural language processing, because those attacks are everywhere and most organizations will encounter them at one point or another.
So Valentin, we've been talking about computer vision in preparation for this webinar. I know it's one of the AI fields that you genuinely love the most. Want to get into that now?
Well, you are right, Aline. I do love computer vision the most, and I'd be more than happy to get into more details. Because unlike the NLP revolution, the computer vision revolution happened 8 years ago in 2012, when Alex Krzyzewski and his PhD supervisor, George Hinton, published a neural network called AlexNet. And by that, they beat every other research lab by 11% difference, I think, in the biggest annual computer vision competition. And in this way, they genuinely brought AI to Silicon Valley. And since then, we've seen thousands of outstanding papers and frameworks and projects. But I believe that one of the scariest projects that I've seen in a while, it's deepfake. Well, in order to understand deepfake, you should understand that it uses generative adversarial networks to transform faces and voices and transfer them from one person to another. It was designed to be helpful in video games industry or in cinematography or in art. But the main problem is that it makes it very easy to impersonate someone else. And a very good example is the project between BuzzFeed and the actor Jordan Peele, in which they generated a video as being the President Obama with the intention to expose the implication behind using deepfake and how easy it is to create chaos and fake news. You will have the link in the description. The main idea is that deepfake didn't benefit from goodwill all the time. And a good example was when it was used to generate a pornographic movie with Daisy Ridley, one of the stars of Star Wars. And starting from there, the next step was generally obvious. Well, deepfake created the next major event in cybercrime, deep nude. Because using the same technology, they created fake news, fake nude photos and videos. And this project was actually banned almost everywhere, but it's very, very widely used and spread, and it's very easy to find it. Well, if you take a look at the statistics, approximately 100,000 women have been targeted and had fake naked images of them shared publicly. And this will lead to a series of cybersecurity threats, because you might wonder, why does it matter for us? Well, first of all, they can create phishing attacks, they can create catfish accounts, can send ransomware attacks, can be used in data theft or in money redemptions.
So how does this work?
Well, the victim, let's say, will receive a nude image of itself and a threat message or a link. And from that point, the attacker can ask for money redemption in order not to share those pictures publicly. They can send a ransomware attack behind one of those images. They can send phishing URLs. They can also create fake payment pages where they can steal the credit card informations when the user pay redemptions, many other tricks.
So how can we combat these?
Well, in order to understand that, first of all, we should understand the generative adversarial networks, how they are training and how they're actually working. Well, when generative adversarial networks train, they train as a fight between two neural networks. First of all, we have a generator that from random noise tries to generate real images as the ones that it was fed with. And we have a discriminator which aims to determine if an image is fake or real, is actually a classifier network. Well, the training is actually a competition between two neural networks that have the objective to beat the other one. And when the training cycle is finished, the generator is the one that is used for creating those fake images or videos. And to respond to your question, if they are using the generator to generate the images, we can use the discriminator to detect those fake images. We can detect them almost with the same accuracy used in generating the images. Of course, the task is more challenging every day because the attackers train their networks too. But I believe that the real question is, does it really matter? Because the victims already knows that those images are fake, and we can't defend them against the denigration and threat of publishing those pictures or videos. I believe that the only thing that we can do is to find those types of attacks in attachments or in emails or websites and protect the victims against other malwares that come with this technology, because once the communication between users and hackers starts, the users are not safe anymore. And from my point of view, this is one of the most dangerous technologies created with artificial intelligence because it creates so many problems that it can hardly be quantified.
So we spoke about the downside of computer vision. I'm sure that's not why I love it the most. But tell us how can we use it for the better?
Well, there are thousands of valuable projects in computer vision, and we have some examples here too. First of all, it proved to be very effective in detecting COVID-19 disease from X-ray. And also, we can detect almost everything from X-rays. And there are hundreds of projects of X-ray cancer segmentation and detection, from brain tumor segmentation, breast cancer detection. We can find skin cancer. I also seen a project a couple of months ago that they can detect bone cancer. And it's very useful in X-rays. Also, it can very accurately detect the human poses. And this is very good in, let's say, video games, in 3D modeling, people tracking, uh, position correction, and many, many inventive solutions. Also, it is essential. I believe that all the car manufacturers right now use computer vision because I've seen many interesting projects in this field, from speed bumpers detection, pedestrian detection, parking assistance, also pothole detection, danger estimation. The main idea is that we can talk about days about the innovations from this field because let's give an example. Last year, CVPR published 1,300 papers, and CVPR is the biggest computer vision conferences. And all of those are incredible projects because it's very hard to be published by CVPR. It's a very serious competition. But let's talk about our field, cybersecurity, because I believe that many from our audience wonder how computer vision is related to cybersecurity. Well, what if I tell you that a malicious website can be classified only from only one image? Well, this proved to be a very efficient way of detecting phishing websites by comparing the infected websites with the original ones, because it's a very good way of blocking websites with disruptive content, because it can easily classify a website and put it into a category like malware website, pornography website, fake shops websites, general information websites, search engines. The main idea is that it adds an extra layer of security against those DNS threats, and it proved to be a very good way to protect our customers against scams. But I believe that even more impressive is the following project proposal. And before jumping into this, you need to understand how the actual antivirus works. Well, the classical pipeline approach for antivirus is pattern matching on signatures. The pattern matching algorithm is used to check a sequence of tokens for the presence of a malicious pattern. It works quite well, but there are still some problems with this approach. Because first of all, it can be tricked by modifying the signature pattern. And also there are too many malware patterns to include all of them in your solution. Well, because of those problems, the classical antivirus lacks what you call the generalization, because it is very sensible to changes in the malware patterns and structure. I believe that to understand better, we can return to our dog example, because it will be easier to understand it this way if you compare a malware with a dog. Well, in antivirus, malware analysts extract patterns from malware. So let's suppose that a malware analyst discovers a new malware pattern, and let's return to our dog example. It discovers that a dog is black and it has fur. Well, if the antivirus or our solution has only seen black dogs or this type of malware, it will not be able to identify white dogs or new types of malware agents because it will lack the flexibility. Well, what if you transform the binary files into actual images? And on the left side image, you can see how a binary file looks like. It's a big sequence of ones of zeros, and we can map those values and pixels to create actual images. And you can see some examples on the right side images. And there are many variations like colored image, pixel random noise, pixel multiplications, many variations. But the main idea is that once we have the images, we can train an image classifier and gain better confidence against those patterns changes. Because as I said before, a well-trained neural network is very robust to change and can be adjusted on detecting new patterns. And this type of intelligent malware antivirus combined with neural networks proved to be very efficient and improved the accuracy in detecting malwares very much. Well, we talked about text and images, but in our field, the data is not always structured. We can extract a lot of unstructured information from a system because it's a very common thing to share data sets in computer vision, and there are plenty of them free of use. But unfortunately, this is not the case in cybersecurity because right now data is an essential resource for every company. And there are some companies that live only from selling data, and trust me, data has a very high price. And this is because it's very hard to acquire, and it's very hard to store it. Well, for those reasons, we need to use every available resource that we have. And that leads to our next chapter, sparse data. Well, if you gather information from a system, how can you use the data in our neural networks and in our advantage? And to respond to this question, I'll use an actual example like the one from the table. In this table, you can see some information about some websites. And here you have only dense data, so they are well structured. But usually in our field, the data is incomplete, binary, and rare. And this is why we call them sparse data. Now, based on that table, we can build the following decisional tree. And once we have the tree and we receive a new domain for which we have the required data, we can classify it. And let's see how it works with an actual example. Starting from the domain, let's say phishing.com. We'll first of all start from the first node. Was it accessed by email? Let's say that it was, yes. It has a login page, yes. Was it created recently? Yes, it was created yesterday. Well, based on this information, you can go through all the tree and the response is in the left corner. Well, it's the phishing. And by the way, example.com, phishing.com, infected.com are not actually infected websites, but I don't want to use real phishing websites in my presentation because I generally don't want to promote them.
Yeah, this really makes sense. But this was one easy example, right? What if we dealt with 1 million websites and 150 columns and incomplete data? How would that work?
Well, building such a decisional tree will be extremely hard because there are some algorithms for building decisional trees with large volume data, but they don't work very well because the results are really far from perfect and it will run very, very slow. It will create a very vast system and running the inference in it will be very slow. However, we have something even more interesting. We have tree-based neural networks, which I'm going to talk about right now. Well, those were very innovative ideas to automatically build decisional trees with learning capabilities in a very significant number. And usually those systems create multiple trees with different dimensions and different features. And together they create a very big, vast voting system that optimizes the loss function. And this is why we say that it has learning capability, because those trees order themselves in a way in which they achieve the best accuracy and the minimum error from a given data set. It doesn't matter the size of a data set, the more the merrier. Where there are some impressive architectures here, like random forest or extreme gradient boosting, that when it was released, it used to win like 90% of the Kaggle competitions. Also, we have ADA boost, cut boost, light gradient boosting from Microsoft. It's the same idea as extreme gradient boosting, only that they change the creation paradigm. One creates three horizontally and one vertically. And those are the most common techniques used by data scientists because it's very hard to innovate in this field of AI, in sparse data machine learning, because the results are really impressive right now and it's almost a solved problem.
So why are they important then?
Because as I said before, we can use all the information extracted from, let's say, a network or a website, computer, IoT, almost every information like IP, geolocation, co-occurrence, consumed resources. We can also remove and analyze malware behavior from a computer. Okay, not every information is relevant or helpful, but it's our job to determine what can be used and what not.
All right, Valentin. So thank you for sharing this this information, precious information, I'd say. It's been a nice journey. But to sum it up, what would be your very short conclusion in respect to the role of AI and machine learning in DNS protection?
Well, from my point of view, a great DNS security engine should be built with machine learning algorithms, data engineering and machine learning patterns, computer science techniques, very robust ones, and it should always be updated using research because we have new malwares out there every single day, and we as the defenders should always be updated and one step ahead of the cyber criminals.
All right. Thank you for sharing that. And now I think our audience is wondering, all right, how can we help to have better DNS security? And there are two ways we can protect your DNS. That's through perimeter security and through endpoint security. And I'll let Valentin tell us a little bit more about it too.
Well, perimeter or network security involves protecting the devices and files from your computer, from your network against unauthorized access. It focuses on protecting the integrity, confidentiality, and availability of your data. It gives you an overview of all the devices connected to the network, because sometimes it's enough to have an infected device to infect an entire organization. And we have some tools that allow the network admin to defend or detect or even isolate all the devices from an organization, from printers to TV screens, guests to even mobile phones and even data centers. On the other hand, endpoint security secures the end user devices like laptops, desktops, mobile devices. It addresses the risk associated with the device that are connected to your network. Endpoint security is different than the traditional antivirus because each endpoint is at least partially responsible for maintaining its security. Also, when many companies adapted to work from home, for example, it became essential to have a very good endpoint protection on every device because classical protection procedures don't apply anymore.
So in this case, which one should an organization implement?
Well, why not use both? Because the advantages of endpoint and network security are not mutually exclusive. There are advantages to using both. With network security, anomalies can be identified and confirmed, and the endpoint can provide clarification in order to better understand where is the actual problem. You should think about this. To help secure our network, make sure your endpoints are secured. But then, on the other hand, you can supplement your endpoint protection by using a network or perimeter security.
All right, so then let's have a look at our perimeter and endpoint protection solution. The first one's Forseti, which is the perimeter security solution. And Forseti is our own DNS resolver. It basically creates a layer of security over the entire network, and it encapsulates the entire network structure, and it defends it against any outside or inside attack. It's a fantastic tool for surveilling the traffic on the network, and of course on the threads that have been blocked. And our DNS filtering technology scans your traffic and blocks access to malicious websites that can, of course, potentially infect your system with malware. So in a nutshell, we maintain a blacklist of malicious IP addresses or web pages, and we ensure that access to them is restricted. And not only that, but by using Dark Layer Guard engine, which is a highly advanced traffic-based DNS security solution, and of course the best DNS filter on the market. With that, our customers can hunt, prevent, detect, and block DNS threats. And next, for Foresight, is our endpoint protection product, and it's a collection of handheld product that includes Dark Layer Guard endpoint, vector and detection, exploit resilience, which is our third-party application patching product, and of course Windows. It handles Windows patches as well. I've been talking about it in our automated patch management webinar that you can find on YouTube as well. And it's basically an exceptional collection of tools for monitoring the internet and the computer activity. And through process correlation, so TTPC, we have that technology that offers the ability to identify users and processes that are at risk and proactively hunt for network-based threats. So Dark Layer Guard offers a full category-based blocking system for system administrators to choose from and basically block access to those categories. And then they can really fine-tune it and define maybe intervals in which that can be done. And Dark Layer Guard and vector and detection are deployed in tandem, so they came together as a package, and they provide the users with HIPS and HIDS, and of course indicators of attack and compromise capabilities by using new neural network transformed AI for device to infrastructure communication to basically stop attacks that traditional antiviruses and firewall solutions are unable to detect. And we also have what we call a Bloom filter that we're using, and this transforms the solution in an extremely low latency one that basically guarantees there's no delay when the users are going to access safe websites. And with that being said, ladies and gentlemen, thank you very much for being part of this journey, talking about DNS and AI in DNS protection. And now let's move to the Q&A session. So I can see there are some questions here, and due to time constraints, I'm not going to be able to answer them all. And I'm going to take a couple and get back to you with an email for the rest. So one is asking me, or us, why are companies at risk right now?
Oh, nice. Can I have this one?
Yeah, sure, man.
Well, we can discuss this topic for hours because, as I said before, DNS is the Internet Foundation, and I believe that there is no company that runs without Internet. And here we can talk about data leaks, data encryption, a competitive advantage, and many other problems that can be caused by an attack because genuinely an attacker can bankrupt a company.
And I think you're right in answering to a little bit of that. Just this year, we've seen unfortunately, we've seen very big names of companies, of course, that fell victim to these types of attacks, and of course our audience can just easily find out about that and by doing a Google research. So unfortunately, this is what can happen if you don't really have a rock solid DNS protection solution in place. Now, another question is asking if the perimeter and the endpoint DNS security products can be purchased separately. So yes, they can. Maybe the confusion was with for Foresight that has the exploit resilience as well. So with Tor Foresight, you can only have the DNS protection part, so the duck layer guard and vector and detection, and exploit resilience, the automated patching solution, can be purchased separately. But of course, you can purchase your endpoint protection through Tor Foresight, and then, as Valentin said a little bit earlier, supplement that protection with Forseti, that's the network perimeter protection solution. And now I think you're all curious to see what the giveaway is. So everyone that attended the webinar can get 35 days enterprise extended free trial, and of course a free of charge, of course, vulnerability assessment. For that, one of our cybersecurity consultants will try to get in touch with you over the next couple of days to provide all the necessary details and next steps for these operations. And also, everyone that attended our webinar will get their hands on a free Tor Foresight home license for 1 year and 3 devices, and that's gonna come in an email in the next couple of days as well. So be on the lookout for that as well. And with that, we thank you very much for your questions. We thank you for the time spent with us today.
Thank you very much, everyone.
And we hopefully managed to provide you with insightful information regarding DNS security and the importance of AI in cybersecurity. Of course, please take a minute to complete our post-webinar survey, as this will help us deliver even better content and materials to you in the future. And until next time, we wish you all good health and stay safe, both offline and online. Thank you very much.